In 2023, the field of computer science has witnessed some remarkable breakthroughs, shedding new light on AI capabilities and quantum computing. From hyperdimensional computing's advancements to the transformation of Shor's algorithm, these developments are reshaping our understanding of computational potential. Too many fancy words. Let's recap 2023 keeping world of AI in mind. First, the evolution of AI, from statistical to hyperdimensional computing. Artificial neural networks, the backbone of statistical AI, have historically struggled with reasoning by analogy, requiring an increase in artificial nodes to enhance their capabilities. This scaling up is necessary to improve the statistical abilities of these networks. Wait a minute, what are artificial neural networks? Let's use a familiar example. Recognizing a cat in photos. How does your brain know it's a cat? It's not because you look at every single detail. Rather, your brain has learned over time what key features make up a cat, like whiskers, furry ears, and a tail. Now, let's talk about how an artificial neural network does something similar. Think of it as a network of many tiny interconnected units, like mini-brains, working together. When you show it a lot of pictures of cats, it starts learning what characteristics are common in all these pictures. Please subscribe to the channel to never miss any updates. Each unit in this network focuses on different aspects. One might notice the shape of the ears, another the texture of the fur, and so on. As they get more pictures to learn from, they get better at figuring out what makes a cat a cat. When you then show this network a new picture, it uses what it has learned to decide whether there's a cat in it or not. Each unit gives its opinion based on its own learning, and then they collectively make a decision. Moving on, in contrast to statistical AI, symbolic AI employs logic-based programming. Wait, I thought all kinds of programmings are logic-based. If not, then what is it? Imagine you have a recipe book for making different kinds of dishes. In this book, each recipe is a set of specific instructions or rules that you must follow to make a particular dish. Now let's say you want to make a cake. You would look up the cake recipe and follow its steps. Mix certain ingredients, bake at a certain temperature, and so on. The recipe is clear, straightforward, and doesn't change, no matter who reads it. Logic-based programming is quite similar. It's like a computer's recipe book. Instead of dishes, it has instructions or rules for solving problems or making decisions. Just like following a recipe step by step, the computer follows these rules to come to a conclusion or make a decision. For example, you could have a rule like, if it's raining, then take an umbrella. In this case, the computer checks if it's raining. If yes, then it decides to take an umbrella, following the rule you've given. It's all about clear, unchanging rules that the computer follows to get things done. This type of programming is very straightforward and is used in situations where rules don't change often and decisions need to be clear. Introductions of these logics lead to hyperdimensional computing. Imagine your brain is like a huge, incredibly complex puzzle. Each piece of the puzzle is a tiny bit of information. Now think of hyperdimensional computing as a way of solving puzzles very similar to how your brain does it, but in the world of computers. Do subscribe to the channel for regular updates. This will add value to your life. In regular computing, information is stored and processed in a pretty straightforward way, like putting together a simple jigsaw puzzle. But hyperdimensional computing does this differently. It takes each piece of information and turns it into a really long and complex string of numbers, like a super long barcode. These strings are like the pieces of a very complex multi-dimensional puzzle. When the computer wants to make sense of them, it's like it's putting together parts of this incredibly intricate puzzle. The cool part is, just like in a puzzle where seeing a few pieces can help you guess what the picture is, hyperdimensional computing can use these strings of numbers to make connections and recognize patterns in a way that's much closer to how our brains work. This approach allows for the combination and deconstruction of concepts to understand their formation. This was followed by breakthrough at IBM Research. In March 2023, scientists at IBM Research in Zurich applied hyperdimensional computing to deep neural networks. They tackled the Raven's progressive matrix, a classic problem requiring an AI to complete a 3x3 image grid. Let's understand this matrix in brief. Imagine you're looking at a 3x3 grid of pictures, kind of like a tic-tac-toe board, but the last picture is missing. Each row and column of pictures follows a certain pattern or rule. The challenge is to figure out that rule and then select the right picture that completes the pattern in the empty space. This puzzle is called Raven's progressive matrix. It's often used to test how well someone can understand and apply logic to visual information. IBM's effort led to an impressive 250-time acceleration in abstract reasoning tasks, a crucial factor for tackling larger-scale problems. What does this actually mean for us? Well, researchers are optimistic that hyperdimensional computing could be faster, more transparent, and more energy efficient than current AI platforms, significantly reducing the carbon footprint of these technologies. Funny thing is, now AI has the capability to write, optimize, and create scripts for YouTube videos and even generate sound and visuals for the same. Things are progressing in such rate that in next few years, difference between AI and human will be negligible. This makes me wonder, are we AI as well, creating self-replicating AIs? Check this video to find out.